Hello friends, welcome to my channel. Let's have a look at problem 942, DI string match. So in this video, we're going to share two strategies or methods. The first one is based on stack abstract data type, and the second is based on two-pointer method. So let's actually we come to this problem from Leetcode 2375. So let's first look at the statement of this problem. A permutation perm of n+1 integers of all the integers in the interval 0, n can be represented as a string s of length n, where si equals I if perm I is less than perm I plus 1, and si equals d if perm I is greater than perm I plus 1. So given a string s, reconstruct the permutation perm and return it. If there are multiple valid permutations perm, so return any of them. So here are three examples. So we are going to have a look at example 1. So first notice that if the string s has length m, so the return is an array of length m plus 1, right? So for example, in example 1, so the length of s is 4. So the return length is 5, right? So this, in example 1, this output is one of the valid permutation. So actually there are some other possibilities we're going to look. So before we do the analysis, let's also look at the constraints. First, s is not empty, and s can have length up to 10 to the power 5, and 10 to the power 5 is actually a decent large number. So si is either I or d, meaning increasing or decreasing. So with that said, let's look at the method we're going to present. So the first method is based on stack abstract data structure, and the second method is the standard two-pointer. So as we come from Leetcode 2375, so actually you can have a detailed analysis for 2375 in this link. So here actually we are going to present one format, that is stack ADT, corresponding to the same idea in Leetcode problem 2375. So Leetcode 2375 actually requires more than this problem. So in Leetcode 2375, so it's required the return is lexico-smallest. So our method 1 actually will give an array. So if we interpret it as a string, so it's the lexico-smallest one, and also satisfy all the requirements in this problem. So let's look at the two methods. So method 1 is following the solution to Leetcode 2375. So there actually we give two formats of solution. So one is just do the reverse by finding the corresponding indices. So, or we can use stack abstract data structure to aid the procedure. So we are here directly present the stack ADT solution. So here's a walkthrough. So in the two solutions here, I'm going to imagine there is a tail I in the string s. So this is the s in example 1. So if we imagine there's a tail I in behind, so we have 0, 1, 2, 3, 4. So the reason we add a tail I or imagine a tail I is just for convenience of writing the code. It's not absolutely necessary. So here, so once we find a transition from D to I, so D to I, then we're going to do the reversing from the beginning of those D's and ending at this one, and then do the reverse. So for example, here we're going to reverse 1 and 2. And also di and 3 and 4. We're also going to reverse 3 and 4. So we're going to have 0, 2, 1, 4, 3. So this is also a valid permutation for example 1. So this strategy would correspond to a lexico-smallest list. So this is the method 1 we're going to write. So the second method is a two-pointer method. So the strategy is very easy and specific to this problem. it means that actually for this problem we do not need to write a code to the extend in method 1. But it's good to know because of Leetcode 2375. So method 2 actually is sort of a greedy method. So each time we meet an integer I, we're going to use the smallest unused number in the closed interval 0 to m. And when we meet in D, so we're going to use the largest unused number in 0 to m. So here is a walkthrough. For example, this is again example 1, and we imagine there is an I in the tail. So the integers we are going to use is 0 and up to 4, right? So when we look at index 0, so the character is I, so the smallest unused number is 0, so we put 0 here. And then we look at index 1, it's letter D, so we are going to use the largest unused number, that is 4. And then if we look at index 2, so it's character I, so we're going to use smallest unused number, that is 1. And then for index 3, we're looking at D, so we're going to use the largest unused number, that is 3. So for the last I, so we have only 2 left, so we're going to use 2. So the return will be 0, 4, 1, 3, 2. So this strategy actually gives an output corresponding to the output in example 1 in the main statement. So with these two methods and strategies covered, we are ready to write the code. So first, I'm going to write a code corresponding to problem 2375. So that is a stack abstract data structure solution. So this actually returns a permutation which satisfies the problem requirement and also is lexically smallest. So first, I'm going to initialize a result, an empty list. So then initialize a stack. And then we're going to do the linear traversal, a linear scan for I and the character in enumerate. So I'm going to put this imagined I in the tail, and then actually the index starts from 0. So we can write here 0 because we are going to use 0 up to the length n. But yeah, we can just use the default. So in this case, first I'm going to append the I to the stack, and then we check if we meet a transition from D to I. If so, we're going to reverse the previous state of the stack and then append to the result. So basically the if condition. So if character equals the character I, then we're going to reverse the stack status and then add to the result. So after that, we need to reset the stack to be empty. So to do the next segment. So that's actually the full solution if we do the return. So let's do a special case check first. Yeah, it passes the example 1, and also the output here is 0, 2, 1, 4, 3, corresponding to here. So it's different from the output in example 1, but it's a valid one. So now let's do a generic case check. Yeah, it passes all the generic cases. So this is the first solution. So now let's look at the second solution, which is easier, specific to this problem itself. So I'm going to mark this one as V1, and then here let me make some annotation. So here it's a two-pointer method. Essentially, it's a linear scan. So we're going to initialize a result variable to hold the elements. So then we're going to set low and high. So this is the lower bound and upper bound about the numbers we're going to use. So the low is 0 and the high is the length of the string, right? So then we're going to notice that counting from 0 up to length s has contain actually length s plus 1 elements, right? Numbers. So then we're going to do the iteration for character in s. Then we can imagine we have a I in the tail, and then we're going to check if character equals I. So we meet an I, then we're going to use the current smallest number, that is low, right? So we're going to append low, and then we're going to increment this low by 1. Other case, so we're going to meet a D, and then we're going to use the unused highest number, right? So we're going to append high, and then we're going to decrement this high by 1. So then afterwards we can return the result. So this is a solution based on the second strategy. So if we do the special case check, it will output this specific result for example 1. Let's do the check. Yeah, this is the strategy corresponding to the output in the main statement. Now let's do a generic case check. Yeah, it passes all the generic cases. So I guess this is the two solution formats. So here is a short summary. The first one is based on stack abstract data type, and the second one is based on the two-pointer method. So it's sort of a greedy strategy. So with that said, that's about it for this video. If you have time, you're welcome to watch the analysis for Leetcode 2375. So yeah, that's it.